So, our story till now. Enter this code, run it, and then read the chapter and understand what it's doing. It's demonstrating pointers. We've seen how to use the star and the ampersand in order to get the address of a variable. And then putting star in front of it again dereferences it so that we can store something in the original space that it was pointing to, so we can change where it's pointing. Un momento. All right, I don't see which chapter talks about references, so we're just going to jump into it without the PowerPoint. A reference is very similar to a pointer. And why have we been talking about pointers? One of the strongest reasons is so that you can pass a variable into a function and then let that variable change it. So our example on Monday was to write something called 0 that would take an integer and set it to 0, and we actually really wanted it to become 0. What do I mean by that? So over here in main, if I declare an integer, like my age is equal to 32, and then I call 0 age, and then I print out age, I really want to see that say 0, and it's not gonna. Because we're not using a pointer, we're not using any special technique in order for it to say age is equal to 32. Excuse me, 0. So it says 32. So age is 32. We pass age in, and since C++, like every other language, unless, well, I won't say that, unless you do something special to try to pass it in as a pointer or a reference, just passes a copy of that variable. So the value 32 is copied into I. And then it doesn't matter. I can change any way that it wants to. You still have your original over here. Just like if I make a photocopy of a dollar bill and hand it to you. You can tear up the photocopy. I still have my dollar bill. How do we fix that? We declare I as a pointer. So this is one way to fix it. Star. And I love the use of P to indicate that it's a pointer. So I'm going to make it my 0 function except star pi. It's a pointer to an integer. And now I have to dereference it. So since I have one P in front of it, I'm going to put one asterisk in front of it. That breaks the call to the function because now it's expecting a pointer. It's expecting an address. How do you get the address of a variable? With ampersand. Okay, now when I run it and print it, it's going to say age is equal to 0. It has actually done what I wanted it to do at that point. Age is equal to 0. The syntax is kind of nasty looking. So when they went from C to C++, Bjorn Strustrup came up with the idea of references, which look like this. I'm going to call this one R0. Or ref0, ref0, because it's going to use a reference. So int ampersand I. This declares I as being a reference. I guess if I followed the idea of P always meaning pointers, I could use R as, ri as a reference. But I'm not going to. So now if I set I equal to 100, I'm going to come down here and call that ref0 function now. And I don't have to do anything special at all. I don't have to pass in the address. The syntax looks exactly like an ordinary function call. So ref0, passing in age. And then let's print out the age again. And then when you run it, you'll see that the second time we print the age out, it's equal to 100. So age is equal to 100. It actually worked. We passed some data in. We passed age in as an argument to this function, and this function was actually able to change its value, which we saw previously was impossible. It's possible because it was declared as a reference. A lot of languages that don't allow pointers don't allow references either. Or they do, but they don't. Don't expect to see that ampersand syntax in Java or JavaScript or Python. They all do what's known as pass by value, pass by copy, which is how the first version of it did before we did any ampersands or any asterisks or anything like that. But since you're passing around reference variables to begin with, since everything in Java is an object, everything in Python is an object, then it's okay. You can still change the values of it. It kind of acts like it's a pass by reference. So I is a reference here. It's a reference to whatever gets passed in. Age and I are the exact same thing now. I is not a photocopy of the original data. It's like I actually passed it that dollar. And so when somebody wrote 100 on that dollar, I print it out here, the dollar bill says it's 100. I guess I should have written 3 examples. Let's rename this example 0p because it stands for, 0 with a pointer. And let's rewrite our very first version of it. Void 0, that takes an int, that's not a pointer, it's not a reference, and then changes I to, some value to 6. And then down here, I want to call 0 with age. That's going to be the first thing I do, and then I'm going to print it out. I'm just going to copy that cout statement. And then I'm going to call P0, pointer 0. That demonstrates, 0p. Meh. Didn't follow my own naming convention. Passing in the address of age. That worked. And then the third way I do it is by passing in age as a reference. I'm taking a couple of spaces out, carriage out, returns out, so I can break it up like that so it'll be easily readable. So some things about references. Since this is expecting a reference to an int, I better really pass an honest to goodness int in there. I can't pass in a 3, a literal, a 3 there, because a 3 is not something that can be changed into 100, Does that make sense? If I went down here to ref0 and changed that word age to a real number, how could that change to be a 3? What is it changing? It can't. It gives me an error here. It says initial value of reference to non-const must be an L value. Okay, that's a lot of, gobbledygook. But, so there we go. You can't pass in a literal constant either as a pointer or as a reference. If you want to, you can store that constant, that literal constant, in a variable and pass it in. If you try to pass in age, but age was defined as a constant, you'll also get an error, I believe. I'm going to declare a new variable. You don't have to type this. Const I is equal to 10. I is probably a bad choice. Const int I is equal to 10, and I'm going to try to pass it in as a reference. Didn't work. Give me a syntax error because if we're trying to pass a constant in here, we have to tell this function that this data is a constant and can't be changed. So we would have to put const here as well. Now, why would you do that? The whole point of passing, something in by reference was so that we could change it, right? Well, if you have a great big object, takes up bytes upon bytes upon bytes. If you can pass it in as a reference or pointer, it's a lot faster than it is to copy all those bytes into a new object up here. So if you don't want this guy to be able to change that data, but you still want him to get a great big object, you can declare to accept a reference or a pointer. Okay, guys, I think that's about enough. I'm going to open up the quiz, the exam. If you want to take it here, that's fine. It's only 5 questions long. I'm sure you can get it done. But if you want to take it at home, if you want to bail now, you can also do that. So let me open it up, and then I'll wander around, and anybody who didn't get this working, now that I've broken it a couple of different times, I need to unbreak it. I'm going to take that word const out from there. I'm going to delete this int ii, and I'm going to change that back to age, and now it's all back to working.